Hello and welcome. In this explainer, we're going to break down the concept of positive externalities of production. We'll start with the standard economic theory and then connect it directly to a fascinating real-world case study that shows just how significant these effects can be.
So here's a question to get us started. Can watering a field in one place actually save lives in another? Now, it might sound like a bit of a strange question, but it really gets to the heart of what we're talking about today. These surprising and often invisible connections within an economy. By the end, you'll see exactly how the economic framework helps us make sense of it.
And this is the core idea. We call it a positive externality. You can think of it as a spillover benefit that's enjoyed by a third party. So someone who isn't directly involved in the buying or selling. And what's really crucial here is that the market price doesn't reflect this extra unintended value.
Right, to analyze this properly, we need to use the standard economic model. For any of you studying for the IB diploma, this diagram is an absolutely essential tool for understanding and explaining market failure.
Okay, here it is. This is the standard diagram for a positive externality of production. Now, I know it can look a bit complex at first glance, but it's really just a supply and demand graph with a couple of extra curves. These help us separate the private costs from the total cost to society. Let's break down what each bit represents.
First up, we have the MPC, or Marginal Private Cost curve. This is basically the supply curve. It represents all the direct costs a producer faces, things like materials, wages, and so on. In our case study, this would be the farmer's cost for water, equipment, and labor.
Next is the marginal social cost, or MSC. This curve represents the total cost to society. Now, because this production process creates an external benefit, like cooler air, for example, we can think of that benefit as a sort of negative cost. It effectively subtracts from the private cost, which means the total cost to society is actually less than the cost to the individual producer.
And finally, to complete the picture, we have the marginal social benefit curve, or MSB. This represents the demand side of the market, showing the total benefit society gets from consuming the good. For this particular model, to keep it simple, we assume that the private benefit to the consumer is the same as the social benefit.
So the crucial relationship you need to see on this diagram is this. The MSC curve lies below the MPC curve. This happens because we subtract that external benefit from the private cost. And that vertical gap between the two curves, that represents the monetary value of the positive externality.
This difference in costs leads us to two very different outcomes. The free market, left to its own devices, is only guided by private costs and benefits, so it will produce at quantity QE. But the ideal level of production for society as a whole, the socially optimal level, is actually at Q star. And as you can clearly see, the market quantity is less than the socially optimal quantity. The good is being underproduced, and that, right there, is the market failure.
Okay, so that's the theory. Now let's apply this to a real-world situation. We're going to dive into a study from the National Bureau of Economic Research that looked at large-scale irrigation in the U.S. High Plains.
The study focuses on something called the Ogallala Aquifer, which is this vast underground water source. It's huge, covering an area of 175,000 square miles. And because it's been used for decades for extensive agricultural irrigation, it provides a perfect natural experiment for us to observe and measure these external effects.
What the researchers did so well was to carefully separate the effects on the farms actually doing the irrigating, those are the private effects, from the effects on areas downwind, the external effects. This allows us to see our economic model of private and social costs and benefits in action.
So, to be clear, the direct effects are the private benefits the farmer gets, like higher crop yields from watering their fields. The external effects are those unintended spillover benefits that just happen to occur in neighboring counties downwind, even though they aren't doing any of the irrigating themselves.
So what exactly were these external effects? Well, the study found that all of this irrigation created a significant cooling effect downwind. This extra moisture in the atmosphere led to a pretty dramatic drop in peak summer temperatures, and this, in turn, boosted crop yields on those neighboring farms, and, quite remarkably, even led to fewer heat-related deaths.
Now, the research didn't just identify these benefits, it actually quantified them in monetary terms. This is often the trickiest part of analyzing externalities, but it's so important for understanding their true scale. First, the private benefit. Over the period they studied, the farmers who were doing the irrigating saw their crop yields increase by a value of $26 billion. This is the direct benefit that drives their decisions. You can see the incentive, right?
But here's the first part of the externality,
Those downwind farms, which didn't do anything differently themselves, saw their own crop yields increase by a value of $7 billion, purely because of the cooling effect created by their upwind neighbors.
And this is where the wider social impact becomes clear. Using a standard government metric called the value of a statistical life, the study estimated that the lives saved due to cooler temperatures had a value of a staggering $14 billion.
So, when we add those external benefits together, the $7 billion for crops and the $14 billion for health, we get a total external benefit of $21 billion. Now, just look at this comparison. The external value that was created is almost as large as the private value that was driving the entire activity in the first place.
So, what does all this data tell us when we bring it back to our economic model? Well, it points to a clear and very significant case of market failure.
This quote from the researchers is just so powerful. It highlights that in some areas, the positive spillover effect on neighbors was actually greater than the direct private benefit to the farmers in that county. Think about that for a second.
And this is our key takeaway. Individual farmers make their decisions based only on their private costs and benefits, which leads to production at QE. They have absolutely no financial incentive to consider the $21 billion of external benefits they create for other people. And as a result, the amount of irrigation in the free market is less than the socially optimal level, Q star.
This leaves us with a critical policy question. Since the free market is failing to provide enough of this beneficial activity, what steps could a government take to correct it? How could policies, perhaps like subsidies, help to align the private incentive with the social optimum? That is the crucial next step when you apply this economic theory to the real world.